Hello and welcome. We are today going to be talking about reflections. So, we did go over reflections just briefly in the overview of transformations. Reflections are a form of transformation, and it's one in which we keep the same size and shape, so we keep a congruent figure. So on the last video that we talked about reflections, we ended up reflecting across the y-axis. One of the most simple, basic ones that you can do. Another one is that you can reflect across the x-axis, and that's equally as simple. So if we had a shape ABC, and we wanted to reflect across the x-axis, we would just say that, reflect across the x-axis. We're just going to be mirroring the image across that x-axis. So what we would want to do is we would want to do one point at a time. This is much easier than trying to do the whole shape, although it is possible to do the whole shape at once. It's just easier to look at each point individually. So let's look at point A first. So it looks like A is 4 to the right and up 3. 4 to the right, up 3. And so to reflect it across the x-axis, we need to bring it down 3 to make it to the line that we're reflecting across, and then 3 more because it's a reflection. So we're going to go down 3. And there will be A prime. The same with B. B will come down. And then C. C looks like it's much, much further from the x-axis, so it needs to go much further away. So it looks like it's 8 high, so we want to go 8 down. And there's C prime. A prime, B prime, and C prime. And as you can see, it has changed its orientation. C was pointing up, and now C is pointing down. This is what happens with our reflection. So that's a pretty simple reflect across the x-axis. If we reflected across the y-axis, if you recall, we would have just been over here somewhere. So that's reflecting across the y-axis. Okay, so we probably want to look at some things that are a little bit more complicated. These are lines that we're reflecting across, and that is something that you want to keep in mind. Okay, so here's just the next, probably more complicated than the reflecting across the x-axis or y-axis, but still fairly simple in reflections. So we're reflecting across the line y equals x. This is actually in y equals mx plus b form already, which is y equals 1x plus 0. So this line is going through the origin. This b is our y-intercept. So the point at which we hit the y line is 0. And then we're just going up 1 over 1. Our slope is 1 over 1. because you can put any number over 1 and still have that same number. So our slope is rise over run. That's a rise of 1, run of 1. So we're going up 1 over 1, up 1 over 1, up 1 over 1, down 1 left 1, down 1 left 1, and so on. So this is our line that we are reflecting across. This is our line of reflection. So we're going to be reflecting C over the line. We're going to be reflecting B over the line, and we'll reflect A over the line. So let's start with point A. Point A is on the line. So what happens to a point on the line of reflection? Well, if you think about it, if you were to smash your face up against a mirror and then look, your face is right up against the mirror, so the distance apart is 0. So we are not moving at all. Our movement is 0. So A is already A prime. A and A prime are the same point because they are on the line of reflection. B, however, is off of the line of reflection. And if you notice, B is at 3, 2, and it takes just one move to get to the line, to the left. So if we went left 1, we need to go up 1. And that would be B prime. I know that sounds weird, but it's true. We could also look at it this way. We want to go across the line. We want to get away from B, across the line. So it took one movement to the left. If we want one more movement to the left, we wouldn't be going with this axis. We need to go up 1. So left 1, up 1. Okay? We could also look at it, if we went from B to the line going up 1, we'd go up 1, left 1. Okay? So either left and up or up and left. Okay? C, we want to count how far it is away, and it is at the 2, so it's negative 2, comma 1, 2, 3, 4, 5, 2, comma 5. So let's go ahead and do a couple more of these then. Probably be useful. There we go. Now we're up to 5 here. So if we're at negative 2 here, it takes 2 to get to the y-axis. 1, 2, and then 5 more to get here. So that's 7. So C is 7 away from this line. So we need to go 7 down. So it's 5 to get down, 6, 7. And that would be C prime. We could have also gone straight down with it. And it takes 5, 6, 7 to get down to this line. And then we're going to go 7 right. So down and right, or right and down. Remember, we want to reflect across. In all of these cases, from B to B, this, from B to B prime, is a perpendicular line to the line y equals x. From C to C prime, if we were to draw a line, is also perpendicular. And then A to A prime didn't move at all, so there's no line to draw. They're just on the line of reflection. Okay? So A prime, B prime. Here's my B prime. I've got so many lines going, I'm sorry. So A prime, B prime, C prime. And that's our new triangle. Okay. You don't really need these perpendiculars. our new triangle. It's just reflected. B reflected, C reflected, and A reflected but didn't move. Alright? So reflections are a little bit tricky, especially when they get into weirder lines. Let's go ahead and try reflecting across a even more complicated looking line. So we're going to try reflecting across the line y equals x plus 2. Graph paper would be very helpful in this problem because x equals 2 or y equals x plus 2, this is not a line that goes through the origin. So it's going to be a little bit more challenging. We're actually starting out, our y-intercept of 2 is up 2. And then our slope, m, is 1 over 1. The number in front of x is just 1. 1 times x is x. And 1 over 1 is just 1. So this is our slope, rise 1, run 1. So this is the line that we're reflecting across. Bring that down a little. Make it look a little straighter there. And let's say our original shape, let's keep our original shape fairly simple here. So we've got 3 comma negative 1. We've got negative 1, negative 1, and then we've got negative 2, negative 2. So those are our 3 points that we're going to reflect. So if you can imagine this shape reflecting over this line, it's going to be somewhere over here in the second quadrant. It started in the fourth. It's reflecting across this line, so it will be in the second quadrant. We can visualize that before we even start. So if we make a mistake, hopefully we'll be able to catch it. All right. So the first thing I'm going to do is I'm going to look and see. I want left 1, 2, 3 to get to the line. So I'll go up 3, 1, 2, 3, and that would put me here. But you can see that doesn't look quite right. We're only 1 away here, and here we're 1, 2 away. So there's something wrong with doing it that way. So let's go ahead and go up. Up 1, 2, 3, 4. Left 1, 2, 3, 4. So I'm also getting a point here. Left 1, 2, 3, up 1, 2, 3. Yeah, so you can see we've got 2 different points. That kind of makes sense. But in fact, to get to the line, it took up 1 over 1, up 1 over 1. So it took up 2, left 2 to get here. So we're going to go up 2, left 2. To keep going. Okay? And that, let's go ahead and name these A, B, and C. So that's A prime. B, let's go ahead and do the same. So we're going up 1, 2, 3, 4, 5, 6. Up 6. So let's go ahead and go left 6. 1, 2, 3, 4, 5, 6. Straight up and down, it's right above point A. Let's also go left with it and see what happens. 1, 2, 4, 5. 1, 2, 3, 4, 5. So again, we're getting a different point depending on which way we go, and that's not good. Over 1, up 1, over 1, up 1, over 1, up 1. That gets us to this point. So if we go over 1, up 1, over 1, up 1, over 1, up 1, that gives us that point. And there we go. Okay. We could have extended this one as well. And that gives us B prime. And then C, we're going over 1, up 1, over 1, up 1, over 1. Oh, that puts us there, okay. Up 1, over 1, up 1, over 1, up 1, over 1. Let's count. 1, 2, 3, 1, 2, 3. There we go. And that is 2 across. This is there and there. Yeah. There's C prime. I've got a few different rules that I'd like to go over. If we're going to reflect across the x-axis, any point that we have that's x comma y becomes x comma negative y. So let's go ahead and look at that real quick. So if we're reflecting across the x-axis, that's this axis here, we can see right away that 5 comma 2, we need to go down 2 to get to the line. So we're going to go down 2 more. And you will get 5 comma negative 2. And that's a reflection across the x-axis. So if this is point A, this is A prime. Okay? And we notice that x stayed the same value, but y changed sign. It went from a positive to a negative. And if we were to reflect A prime to A, the negative would become a positive. So whatever our values of x and y are become x comma negative y, or the negative of whatever sign it is. So a negative negative 2 would be a positive 2, and a negative 2 would be a negative 2. So we would be switching back and forth. So that's reflecting across the x-axis. And we could pick any point on here. A was just a simple point that I've chosen, and to go from A to A prime, we're just reflecting across the x-axis. The y value changed sign. That's it. Okay? If we were to reflect across the y-axis, that would be x comma y becomes negative x comma y. So the y stays the same, but x changes sign. So let's go ahead and see if that's true. So we're going to reflect across the y-axis this time. So we need to go left 1, 2, 3, 4, 5 to make it to the line. So we're going to go left 5 more. And there it is. We're going to call it a double prime. And that is negative 5 comma 2. And that point is now reflected across the y-axis. And does that hold up? X comma y became negative x comma y. The x changed sign, but the y stayed the same. So this is correct. All right, the next is y equals x. So the line y equals x. this is the line, and it means that y equals mx plus b, y equals 1x plus 0. So 0, 0 is our intercept, and 1 is our slope. We're going up 1 over 1, up 1 over 1. Okay? Or down 1, left 1, down 1, left 1. Okay? So to reflect, A, we could go left 4 to get, left 3 to get here, and then we would go up 3. Left 3, up 3. So left 3 from 5 is 2, and up 3 from 2 is 5. So left 3, up 3. And this would become, we're going to call that a triple prime. So that's reflecting across the line y equals x. And notice when y equals x, x comma y, they swap positions. So whatever your x value is becomes your y value, and your y value becomes your x value. They switch. So is that true? 5 comma 2 became 2 comma 5. They just swapped positions. So if you're going to reflect across the line y equals x, it's really simple just to remember that the two numbers swap positions. Okay? And the last is y equals negative x. A little bit more confusing, but we can do it. If y equals negative x, that's still in the form y equals mx plus b, y equals negative 1x plus 0. So our y-intercept is still 0, 0, and our slope is negative 1 over 1. Okay? So we're going to go down 1, right 1, down 1, right 1, or up 1, left 1. Okay? So this is our y equals negative x line. And if a is 5, 2, we're going to go left 5, 6, 7 to get to the line. So then we're going to go down 7, 1, 2, 3, 4, 5, 6, 7. And we'll be right there at negative 2, negative 5. And that will be on a quadruple prime. Okay? And if we look, 5, 2, they swap positions to 2, 5, and they both become negated. And that's correct. When y equals negative x, xy becomes yx, but it's negative y comma negative x. So it changes sign as well. So we've got our different movements. You can reflect across any line. These aren't just the options. These aren't the only 4 options of reflection. You can reflect across any line. You could reflect across the line y equals 3x plus 2. But it gets a lot more complicated. And we're not going to worry about that right now. I want us to practice these 4 and get really good at them. Okay? So let's go ahead and give the assignment a shot. Remember, we've got our original point, and then I've got a few different points up here. The A prime is just indicating the x-axis reflection from A. A double prime is the y-axis reflection from A. And the A triple prime is y equals x reflection from A. And then a quadruple prime, the quad prime, that is the reflection across the line y equals negative x. Okay? So hopefully it's not too messy. You can see what everything is doing there. These are the 4 reflections that I want us to get really good at. And then we can move on. So if you have any questions on the assignment, please Canvas message me. And thanks for watching.